Chris Benet here, your blockchain beard guy. Hope you guys are having a great day. I wanted to talk to you a little bit today about IPFS, the interplanetary file system. And I'm cheating here a little bit because I've already done a few videos on IPFS, but that's okay. IPFS is really, really cool, and it deserves a little repetition because it's not on the radar of a lot of people. And if you're not familiar with IPFS, if you haven't checked it out, I really, really recommend carve out a little extra time in your schedule some night or on a weekend. Take a look at IPFS. It is an amazingly cool project. So what is IPFS? Well, what IPFS is it is distributed or decentralized content storage. And for the IPFS story to make sense, I'm going to back up a little bit and talk about cryptographic hashing. You may or may not be familiar with the concept of hashes. If you're not, the name sounds a lot more intimidating than the concept actually is. The idea behind a cryptographic hash is it's a mathematical function that you can use to create a unique identifier for a piece of content. In other words, I can put anything I want into a cryptographic hash function, any piece of data, right? It could be a spreadsheet, it could be a Word document, it could be some plain text, it could be a web page, it could be a movie, it could be any kind of information at all. And I put this as input into a hash function, and when I get back out is a unique identifier based on that input. And if I changed anything about that input, no matter how small or how insignificant, I would get a very different hash value back out. And the only thing that will ever generate that unique hash value is that specific input. There's no other input that's going to give you that same hash output. So just tuck that away in the back of your mind and think about something else. And that is the fact that right now the internet is location-based, meaning if you go to the internet and you type in a URL like linkedin.com or facebook.com, well, as soon as you hit enter to pull up that page, what's going on underneath the scenes is there's a service called DNS. And DNS translates that nice, friendly URL, linkedin.com, google.com, amazon.com, translates that URL into what's known as an IP address. And an IP address is just a series of 4 numbers separated by dots. So you might have something like 192.168.1.116. And each of these IP addresses points to a physical location on planet Earth where that computer or that server resides. So the way the internet works today is a bit like mailing a letter. We create some content, we put an address on it, and then if you want to find that content, you have to go to that physical location. And this has served us pretty well so far, but it's not necessarily the best way to organize content. And we're going to start to see some of the limitations of this approach shortly. If you think about it, addressing content by location is not very effective. Let me give you another example. Let's say that you love a good murder mystery novel, and I just read a really, really great murder mystery. And the whole time I was reading it, I was thinking about how much you would love this book. So you and I are having coffee one day, and I tell you, you've got to read this book. I just read it. It was a great book. I know your tastes. You will love it. And you get excited, and you say, wow, Chris, I really want to read that book. How do I get a hold of it? And rather than tell you the name or the author or the ISBN, rather than describe the content, what if the answer I gave you was a physical location? What if I told you, hey, if you want to read this book, you need to go to the New York Public Library, and you need to go up to the 2nd floor, and you need to find the 3rd shelf in from the left, and it'll be the 4th book in from the right. So you buy your plane ticket, you go to New York, you check into your hotel, you wake up the next day, you go down to the library, you walk up to the 2nd floor, you find the 3rd shelf, you go to look at the 4th book in from the right, and it's checked out. So you got to go back home, wait a couple weeks, buy another plane ticket, go back to New York, go to the public library, right? anyway, this is probably striking you as a pretty foolish way to get you to find that content. What would be much better is if I told you the name of the book and the author of the book and maybe the ISBN number of the book, and then you could determine where to get it. You could get it at the New York Public Library. You could get it at your local library. You could get it at your local book retailer. You could order it online from Amazon. You could borrow it from a friend. Where you get the content doesn't matter as long as you get the right content. Well, IPFS is attempting to do the same thing for the internet. Instead of a URL pointing to a physical location, a URL in IPFS points to a piece of content. This has several really big advantages. Number one, it creates an extremely fault-tolerant network. If one server goes offline, that's okay. If other machines have that content I'm looking for, I don't even notice that machine being offline. You'll probably appreciate that if you've tried to log on to Wells Fargo or Facebook.com anytime in the last month. Another interesting value proposition behind IPFS is because each URL is a hash of the content you're requesting, you have an implicit guarantee that you're getting the right content. If I gave you a traditional URL that pointed to a location and told you to go access a piece of content at this address, how do you know you're getting the right content back? How do you know that piece of content hasn't been changed or altered or intercepted in the middle and replaced? Well, with IPFS, you have that guarantee. Because if the bits that you were requesting generated a different hash, you would be going to a different URL. So anyway, in closing, if you have not played around with IPFS, the interplanetary file system, it is a really, really cool project. Go to IPFS.io and check it out. They've got some great documentation. It is really, really easy to stand up your own IPFS node and start playing with the technology. And what's really cool about IPFS is it's a protocol. It's just like Ethereum. Just like you can run the Ethereum mainnet, or you can stand up your own private Ethereum networks, you can do the same thing with IPFS. You can jump onto the main public gateway, or you can stand up your own IPFS networks privately to share and manage content in a decentralized format within your business networks, within your trade networks, consortiums, value chains, supply chains. So just really, really cool technology. So again, check out IPFS.io. You can learn a lot more. It is a very, very easy technology to come up to speed on, and a really, really cool tool to have in your toolbox as you're designing distributed and decentralized solutions. So hope this has been interesting. Hope you guys dive into IPFS and enjoy it as much as I have. Until next time, I'm Chris Benet, your blockchain beard guy. Hope you guys are having a great day.